Yeah, good morning, everyone. So it's a brand new day. And in this lesson, we will be focusing on theorems in circle. You can't get away from this topic. The just ended WASI. I think the last question 13, was all about this. Every year, WAEC brings question under this topic. So if you take this very seriously, you will be good. Yeah, it will be good. So let's begin. Um, so plane geometry 2 is all about circles and its theorems or properties. Okay. Now the theorems of circles are eight. How many did I say they are?
Eight.
Eight. So once we are done with the eight theorems, we're done with the topic. Okay. Now, before we begin, if I start discussing the theorems with you, there are technical words used in the theorems you will not understand. Words like circumference, sector, and stuff like that. Okay. So I will start you off by introducing you to the circle language. Okay. And then once you understand the language, we can look at the theorems. Is that okay? I hope it makes sense.
Yeah.
Okay, so to begin, let's look at what a circle is. So typically, we know what a circle is,
Yes.
right? Yeah, but in if any random person asks you what's a circle, I'm not sure you're gonna do this, right? We should be able to define it mathematically. So let's try. So a circle is defined as the locus of a point. Hold on. The locus of a point equidistant, the locus of a point equidistant from a fixed point. Guys, are you following?
Yes.
Okay. Have I done this with you already?
Yes. Yes.
Interesting. Then why am I teaching it again?
We didn't finish. They wanted to tell you that it's okay.
Uh, so all of you in the classroom were present for this class.
No, sir. No.
The
Yes.
person will ship you guys, so who is saying they do?
Dennis.
Okay. Anyway,
Right.
Venice will do it for you, eh?
Okay.
Why Rahel was in a school?
Yes, sir.
Okay. So it's fine. A circle is defined as the locus of a point equidistant from a fixed point. How the hell will you be defining a circle with complex languages we don't understand? Are you feeling that way too?
Yeah.
Yeah. So we would break it down. So I think a circle is defined as those are simple languages we understand. Locus of a point. Locus is a problem. Equidistance is a problem, right? So let's look at what locus is. Okay. And equidistant, what it means. Shall we? Shall we?
Yes, sir.
Yeah. Locus is defined.
They are practicing in school.
Okay. Who?
Patience,
Uh,
machine.
Okay. Locus is defined as the path, a point, traces Okay, obeying certain rules. Locus is defined as a path a point traces, obeying certain rules. Yeah. Let me know when you are done. Oh, I'm waiting for you guys.
Oh, yeah.
You never told me. All right. So I said locus is defined as a point traces obeying certain rules. So do we understand what path means, right? Path.
Yeah.
Yeah. Yeah. So um locus, the idea of locus stems from construction. Do you remember geometric constructions? Construction. Do you remember construction?
Yes.
So the idea of locus stems from geometric construction. Now, it's when we talk about locus, locus is a path point traces. Okay. So for example, it is assume that when you have 2 points on a straight line, or what should I even use? Um, I'm coming. I'm trying to get an example. Yeah, so if you remember geometric construction very well, you have points, 3 points that that gives what? That forms a triangle. Okay. Who is talking on the background? Yeah, so you have a triangle, 3 points that actually forms a triangle, and um you'll be given certain properties, okay, or certain rules, and that those rules actually make you draw, I mean, arcs. I don't know if you remember that. Arcs
Yes.
make you draw arcs, and at the end of the day you get a circle revolving around all the points of the triangle. This circle is a locus. Do you understand? This circle is a locus. If you have a point on a straight line, okay, another one is you will have a point on a straight line, and so these are the 2 points actually, point C and B. you are made to draw an arc. At the end of the day, this becomes its locus. All right. Yeah. So the locus is what? A straight line, meaning the path it traces is what? Here. Yeah. So, well, there are rules to that. I'm not here to teach geometric construction. That's why I don't want to expand on it. I don't want to expand on it. So I'm going to give you one rule that defines circle. So this is what happens when you have now pay attention. So I'm going to teach you one locus, okay? Yeah, so when you have a fixed point, okay, you have a fixed point, and then you have other points, and those points are such that the distances from the fixed point to those points are equal. So you have other points, okay, and those other points are such that the distances from those points to the fixed points are equal. You get it like that, equal. Hmm? You see, hey guys, okay. So what did I say? So I said we're looking at one locus, and here are the rules. If you have a fixed point and you have points that are such that the distances from those points to the fixed point are the same. What it means is that if you measure from this point to the fixed point and you are getting 5 centimeters, this fixed point to this point is also 5 centimeters. This fixed point to this point is 5 centimeters, like that. Please, are you there? When you have a, these points, when you have points behaving like that, a fixed point and the distances from other point, choosing points to the fixed point are the same, okay? From each point to the fixed point is 2 centimeters each. It's the same. Then the locus, the path to those point trees is what? A circle, a circular path. Yeah. The path to those point trees is a circular path. Did you get it? So what is the rule to get this locus? The rule to get this locus is you must have what? A fixed point. And then, yeah, you must have other points. But note, the distance from those other points to the fixed point must be the same. So if it's 4 centimeters, it's 4 centimeters all through. Do you understand? It's 4 centimeters all through. So there's a point. So you have points A, B, C, D. And the distances from those points to the fixed points are the same. Then the locus of those points, okay, the path of those points, A, B, C, D, E, the path of those points is what? A circular path. You get it? Yeah. Jessica, do you understand?
Yes.
And it's so true. When you take a circle, okay, any point on the circle to the fixed point is the center. When you have a compass and you make a circle, the compass leaves a hole, right? The compass leaves a hole. Where the hole is the center. Any distance on the circle to the hole, okay? Any point from the circle to the hole is always the same. You can choose any points on a circle. If you measure from the circle to the middle part, the center, is always the same. Who don't know of this? Rahel, do you know of this?
Yes.
Yeah, so that's it about locus. Please, can I, and I've also used that to define what a circle, right? So circle is defined as the locus or the path of a point that is of equal distance from a fixed point, right? The path of a point that is of equal distance from a fixed point. By the way, equidistant means it's distance is the amalgamation of two words. And I believe you understand amalgamation. Sorry. Is that, do you understand when I say amalgamation? Amalgamation means the mixing or joining of two words. What are those words? Equal and distance. Yeah, you're right. Amalgamation means mixing or joining. Can we move on? So I believe you've been able to document stuff now. Shall we? Who is missing?
Fat.
Patience, are you missing?
No.
Okay. Once again, the reporting time is 8 o'clock, not 9 o'clock.
Yes, sir. What's true?
So madam's still in the room.
Yes. Yes, please.
Yeah, madam, please go to the office and work on the items I sent you.
Miss Mandy. Shall I say it? No, just must listen.
Does she hear me?
Yeah, she's gone.
All right. Let me know if we can continue.
Oh, we can.
Okay. So, I heard we can. Am I correct?
Yes, sir.
Okay. So now I want us to look at the properties. Sorry, part of a circle. Okay. That's the language. Yeah. So part of a circle. So the circle has some parts, and in fact, it's the part that is used in the theorem. So if you don't know the parts, it's hard to understand the theorem. So part of a circle. Yeah. I'm coming.
Okay.
My ruler is very stubborn. I've never been used to regulating it. Okay.
Say if I shut the room, please. Say no, it's not. We don't want it to read.
What are they saying?
They say that Charlie, there's no. Let's go.
Okay. All right. So let's look at the parts. So number one, well, I'm not going to discuss all the parts. Some of the parts are used in mensuration. There is a topic called mensuration, but I'll only write the ones we use. So we'll start with circumference. Then number two, we'll look at arc. Number three, we'll look at chord. Number four, we'll look at diameter. Number five, we'll look at um radius. Yeah, segment. let me talk about sector so that one day when you go and you meet it, at least you're not lost. Can we move on?
Yes.
So let's start with circumference. So last time I defined them for you. What it is? What is it?
That's fine. The last, what is
It is the circular part of a circle. Shall we? Hello.
Hi.
Yeah, so it is a circular part of a circle. So right here. Now, what is important is understanding it. So let's take the circle. Now, to understand what the circumference is, so let's note a point on the circle. So I will note here. You see it. Now, if we talk about circumference, then it's from that point I noted on, oh, sorry, on the shell. That point I noted, okay, on the shell. Oops, I mean the shell. Why am I entering in? You see? And back again. Yeah, I'm back to the point again. See, I want to walk on the shell. It seems to be coming inside the circle, but that's not what I want to do. So the circumference is the black line, the pattern. So from here all the way and back is what? Is circumference of the circle. So you notice that I didn't see this point, from this point, maybe from that point and let's say to here. No, right? I said from that point all the way and back to the point again. That's circumference. Let's look at another one. So take a look at the circle too. To understand what circumference is, so let's note a point on the shell. So circumference is from that point all the way right on the shell and back again, right? So it's the
Yes.
black part, the black pattern. That's the circumference, everything. Okay, so that is it. So if you start, you rotate 360 and back again. That's the circumference. Hmm? Yeah. So because it's everything, another name we give to the circumference of a circle is what? The perimeter. Perimeter of a circle. So if you ever meet this, perimeter of a circle is the same as what?
The circumference of the
Circumference of a circle. Can we move on?
yes.
So there is this topic in mathematics which is called mensuration. I'll write it on the left hand side. Mensuration. So there's a field in mathematics that deals with the measurement of area, the measurement of area. Yeah, the measurement of length, area, volumes of plane and solid figures. Okay. A circle is a plane figure. So the measurement of length, you know what length is, right? Length, area, and volumes of plane and solid what figures. That's what mensuration is about. So in the field of mensuration, the question they will ask you about circumference is find the circumference of a circle. Find the circumference of the circle. So what it means is that if the circle is drawn to scale and there is any instrument you could use to measure the length of the circle, to measure the length, it's all about noting a point like I've noted. Then you measure from that point like to and back again. Do you get what I'm trying to picture? Yeah, then you measure it. You measure it. So if they ask you to find the circumference of a circle and the circle is run to scale, that's what you have to do. Okay, let's move on. So the next on our list is arc. Let me know if you are ready. It's important you draw the figures and note some information down for future reference. Let me know when you are ready and I can continue. All right, arc. It refers to the length of the line segment between 2 points. On the circumference. Yesterday's solution was interesting, where we had to introduce logarithm. I believe you had time to go through.
Yes.
Okay. It refers to the length of the line segment between 2 points on the circumference. Shall we?
Yeah.
So, um, let's have our circle. We are still out on the outside. So let's note a point on the circle. We are still outside, so we can note a point outside. In fact, let's note 2 points. So you can name this point as E and name this point as B. So the distance from E, right, to B is an arc. Yeah, it's an arc. Have you seen it?
Yes.
So you see, circumference is when you note a point, everything. But arc is just a section of the circumference. So if you note a point, we noted 2 points. The distance from that point to that point is an arc. In fact, if you're looking underneath, the distance from that point down to B is also an arc. You see it? So we have two different arcs here. If you're looking above, from A to B is an arc. If you're looking below, from A to B is what? An arc. There are two different arcs here. Let me know if you understand arcs before I add an additional information.
Yes.
So we have two types of arcs. So we have major and minor. Okay, so we have two. So we normally use the word major and minor to differentiate them in circumstances like this. going forward, you see that major and minor can also be used for one of the items here. We'll come to that. So major refers to the one per your discretion you deem as big. Okay. The minor is what? The small arc. Do you get it?
Yes.
So we have A and B. An arc is up above, an arc is below. So per your description, which arc is the major arc?
The B to A.
Come again.
The B to A. The down one.
Down one is what?
The measure one.
Yeah, the down one is the major one.
The top is the minor.
The top is the minor. Let's continue. So I can give you another circle. Okay, so let's take note of 2 points here. We have A, so we can name here as, no, let's use different letters, M and N. Hmm? The distance from here, you see, this is an arc, right? Have you seen it? MN is an arc. And then the distance from that is also an arc. Yeah, so now, so there are two arcs, right? One is on the right, one is on the left. So how would you call them? The one on the right is what?
It's the minor.
Arc. And the one on the left is what? Okay. Andrews, please go to the office and do something briefly for me. When you go there, Madam will let you know. I'm going to pause the lecture and wait for you. Okay. Can we move on? Yeah, so that is it about arc. Let's move on. Let's go to chord. Let me know when you are ready. Andrews might have to write.
They are ready.
Andrews, are you ready?
Yes, I'm here.
No, are you ready?
Yes. Yes.
Chord, okay. So it is a straight line It is a straight line that touches 2 points on the circumference.
Andrew's right. I'm right.
It is a straight line that touches 2 points on the circumference. Shall we? It is a straight
Yes.
line that touches 2 points on the circumference. So let me know when you are ready.
There, I'm finished. You are ready?
Okay. Now we have to let's discuss straight lines in depth. Okay, straight lines. So everyone is used to this kind of straight line. This one. That's
Yeah.
that's all. That's all you know. So
They're
if
not only that.
okay, if you give them this, okay, this one today can tell you it's a straight line. Now this is where the problem
Yes.
comes. When you give them this and you ask, is it a straight line? They sometimes well, I understand now. Many of you know because I did some training with you back then. But others will see it's not a straight line, but it's a straight line. And that's a problem. If you fail to admit that that is a straight line, then it's hard for you to know what chords are, you see. So this is also a straight line. So as far as the line doesn't look bent like that, it's a straight line. Do you get me? Are you guys on?
Yeah.
Can you hear me?
Yeah. Let's continue.
So those two lines on the right are diagonal lines.
Okay, now.
Yeah. And then this line, the first line, maybe I should label them A, B, C, D. So C, D are diagonal lines. E is a horizontal line. And B is a vertical line. Okay. Are you guys on?
Yes, sir.
Andrews, why don't
Sir.
you, sorry, let me stop this recording. Yeah, because that will give you a big look here. Okay, so um yeah, so horizontal line, vertical line, then diagonal lines, yeah. Okay, hold on, let me take this call. So where are we at? We're talking about the lines, right? Can you hear me, guys?
Yes. Yes.
So that said, now let's take a look at the circle. Okay, now we have a chord. Okay, yeah, we have a chord. So let me explain. Now we are inside. So this is a straight line, right? Now we define a chord as a straight line. That is what? That touches 2 points on the circumference. It touches 2 points on the circumference. So that's a chord. Now, it's a chord because it's a straight line. I've already discussed a straight line. And it's touching all the 2 points on the circumference. So that's why it's a chord. If it fails to even, if it fails to meet one of the requirements, it's not even a chord. Let's look at this one. So this is not a chord because it's a straight line, all right, but it's not touching 2 points on the circumference, right? It's just touching a point on the circumference. Are you following, guys?
Yes.
Is this a chord?
No.
No.
Hey,
Yes.
you're not even wait for me to finish. Is this a chord?
Yes. No.
Is this a chord?
No. Yeah. No. It's not touching, but it's not. But so no.
That's all. It's not a chord.
Yes.
Give that person food, the person that said yes.
It's better.
Mm.
What's that Indian breakfast? This deal.
Okay, let's move on.
Hey, it's 9 o'clock. So what time is
She's
it?
trying to remind me. Tell her I did not hear anything.
You heard.
Mm. Can I move on?
Yes, sir. I'm 5. I will be 10.
Now worry, go for break soon.
Watch it.
You guys are not serious. Okay, diameter. You let me finish. I will allow you to go and buy your watching.
Yes, sir. So watching our son. Yes,
Diameter. Are we here?
Yes,
It is a chord. I should have asked you to do this, but I'm going to do that because I want you to go for your break. So it is a chord passing through the center of a circle. The center of a circle. So it is a chord passing through the center of a circle. Shall we?
Yes.
So you know chords, right? Yeah, so now for diameter, you must be told there is a center. Here, you don't assume for anyone. Every question that you are given, if you are not notified that the center is a center, then there is no center. Okay. So now for all the diagrams I've been drawing underneath, O is a center. So you see, I've notified you. O is a center. Now, the moment O is a center, I mean, you are told there is a center. Any chord, okay, that runs through the center of the circle is a diameter. So it's a normal chord, but the moment it now runs through the center of the circle, it's not a chord, but what? A diameter. So that's it. It's not hard. So I can give you more. Again, O in this diagram is a center. So is that a diameter?
Yes, sir.
Okay. So there's a lot to go for your break.
So let's finish with the by the characters, the parts.
Sure.
Yes.
You after break, I will touch on I'll try to
Oh.
find before we have signs, so it's not a big deal.
Okay. Okay.
So O is a center.
Who is the center?
Is this? Oh, hold on.
Yeah, then.
My hand was shaking a minute.
Okay.
Is this a diameter?
No, sir.
Why?
Because it's passing through the center of it, but it's not getting to the other end of the cell. It's not
Yeah, it's
touching
not
the.
even a chord because it's
Yes.
not a chord, right? It's not a chord because it's a straight line, but it's not touching 2 points on a circumference. And to be a
Yes.
diameter, you must be a chord passing through the center. You are not even a chord to think of that. So, yeah, that's it. Any question?
No, sir.
What?
Okay, so this brings us to the end of this lecture session. Of course, we'll make another recording again when you are done with your break. We'll be looking at radius, segment, and sector. So you may go for your break and come back at, you are writing. So let's say 10:38. I'll give you an additional 3 minutes to do your writing. Goodbye.
Yeah, that right.
Okay.
Yeah,